Hello, everyone. So actually, I thought this was a lightning talk as well because I prepared it in like 10 minutes. Firstly, I had done this work almost about more than a year back, so I'm hazy on the details. So if you want the details, maybe we can talk later and I'll scratch my brain to find that out. So this talk is basically about talking about one of the projects we did where one customer, one client had an app which was very slow. And they were like, why is this app slow? I'm using open source tools. I've built it on open layers. I've built it on GeoServer. It's still slow. Should I go with Esri or one of those other things? And we said, no, wait. Let us test your app out completely. Let us figure out what is going wrong, and then let us tell you or give you recommendations on what you should do to make it better. So the basic thing was that the users were having an open layers based application which had WMS services, a couple of WFS services, and so on, and it was taking very long. And this is one thing which I often hear when we are talking to users is something is fast or something is slow. But very often it happens that the developer might say it's fast on my machine, why is it slow there, right? So there are some things which we can do to actually test this out, and that is what I'm going to talk about. So when somebody says something is slow, I would say, okay, let's keep GeoServer aside, let's use something like vector tiles, which will be very fast. That would be something quick and easy to do. But in this case, for certain reasons, the client didn't want to do that. So we said, okay, let's actually go into detail and see what can be done. First, we actually tested the application in detail and looked at what is possible. We found that every time the user zooms and pans in the map, it is taking a long time for the data to come. How long? 3 to 11 seconds. Now, in today's world, is this acceptable? Of course not, right? I would say it was not acceptable even 5 years back, 10 years back. But still today, there are apps which are very slow, and we need to do something about it. So the conclusion one could draw is that we really need to actually take a step back, think about what the application is doing, and then make certain changes and targeted intentional changes. And so after looking at the app and we said, okay, let's test it out and see what is going on. When users say it is slow, even I as a user, when I tested it out, I said it is slow. I said, let me test out what is happening. I looked at some of the requests that the app was making, use JMeter for testing, and these are the numbers which jump out at you. When you look at it, we just tested with 500 concurrent requests, not users. And when you do that, you will see that the requests, this is in milliseconds, the average or the 99 percentile is something that we can look at, where it means that 99% of your users are getting speeds or times less than this. So what we are getting is 99% of users were taking almost 10.6 seconds for that basic cadastral layer in their application. Again, this is something which is completely unacceptable. Users would not use this application, the client would go bankrupt, and nobody would be able to get that geospatial data which this was serving out. So we had to make certain recommendations. And these are the recommendations we made. Firstly, we looked at it from the database level onwards. We found out that the data was stored in the Postgres database in a wrong format. Because it was polygons, you need not have to store it in multi-polygons, or if it was multi-polygon, store it in multi-polygons. But it was being stored in a geometry column. So we said, okay, let's convert the data from the geometry column to a multi-polygon geometry type in your Postgres database itself. This will make it faster. We also looked at whether there are any spatial indices. There were none. We thought this was a very high impact quick fix which we could suggest. And this was even surprising when we actually implemented it. Some of those requests went down by 95% by just putting a spatial index and the geometry column converted to the right type. So there are these small things which you need to think about when you are building applications. Don't just put data in a database, put GeoServer in front of it and build your app on it. It's fine if you're doing a POC for your own use or just showing to the client that this is possible. But for production level application, you really need to think about in detail. Then we looked at the GeoServer level. In this case, the client was not running it directly in the Linux machine, but they were using Kubernetes and they were using a Docker container. So then we looked at all the parameters that were being used in this Docker container. Sometimes you have to go to that depth to actually extract the last kind of usability out. And so then we actually looked at the parameters and we said that, okay, the parallel garbage control also has to be increased. And so that is one of the parameters which we suggested. Then we realized that none of the layers are using any caching at all. So again, this is a high impact kind of recommendation that if you make this one small change, there'll be a lot of difference in the usability of the application, the user experience itself. And GeoServer comes up with, comes out of the box with GWC, which you can use. And GWC is very often transparent to the user. What I mean by that is if you use just one parameter in your WMS request and you are making requests for tiles, it automatically gets cached by GWC. So this is something that you can look at as well. Then we said, then we looked at how the data was being edited, because we are saying let's cache it. But what happens when the data gets edited? The user should not be shown the old data, right? And that is what would happen when you have tiles and caches in your being served out to users. So you need to have some way of programmatically invalidating the cache. Then one more thing which we looked at is that even though the application had some kind of user login, the layers by themselves did not have any user login at all, or there was no access control on them. And since the client was dealing with some kind of proprietary data which they didn't want to use out, it was not a government agency, it was a private agency. So we suggested certain methods in which they should lock down their layers, and also suggested the way in which it could be used in the app which they have built. Finally, GeoServer also comes with a monitoring extension which you can enable. Now, why this is important is, again, users were saying it is slow, but the developers or the people behind the app did not know it was slow. They would have known this if they had the monitoring switched on and they looked at those values. So therefore, we suggested that this is also which should be enabled. Finally, now coming to the open layers level, the application, for some reason, allowed users to zoom into zoom level 30. And the people thought that this is quite normal. Of course, I want to zoom into more, right? And we said, this is completely crazy. It's bonkers. Why do you want to go to zoom level 30? And this is a table which I showed to the user to actually make sense. Even we don't realize this. Most commercial web apps only go up to zoom level 20 or 19. And if you go to even say zoom level 24, that's your entire map would cover the size of this table, for example, on your screen. So do you really want to go to zoom level 30? Because then your area that you're seeing on the screen is actually much smaller than, say, a pen, the tip of a pen. So therefore, we have to show this to the user that this is not what you want to do. Even though numerically it makes sense, when you put it like this, suddenly the users understand what these zoom levels actually mean. Then coming to open layers, the second thing which we also found, which was again a big high impact on the slowness of the app, was that they were not requesting tiles, or they were not requesting small areas. They were requesting for the whole viewport. Now this is a problem because if you pan slightly also, instead of just the new area of the map being called from the server, the entire viewport was being called. So using tiles would definitely improve their application, even if you did not enable caching. And one more thing which we noticed was that they were not using WFS for writing data. Like as I mentioned, the cadastral layer was editable to certain users. And you could suggest that, okay, if I'm really, that GeoServer comes with WFS, let's use that. Maybe people might not agree with me, but I think that WFS is not very user-friendly. So they were having some PHP scripts and PHP APIs which they were using. And I said, that's fine, because at least that was the fast part of the application. When you had so many other things happening on GeoServer, even the WFS was slow. This is all recommendations in theory. What happens when you implement it? And this is something which people often don't talk about, that we can just tell people do this, do that. But when you go to do it, suddenly there are known unknowns and there are unknown unknowns, as somebody had once said. And these were some of the unknowns we had faced when we actually implemented it. Firstly, if you notice the speed which I mentioned, 11 seconds, that is a kind of speed which one user saw. But the customer actually wanted the app to support 600 concurrent users. And you have 14 layers. So when you multiply 600 users by 14 layers by 100 tiles, as an example, you have so many requests happening per second. Now, I can say that GeoServer is not supporting this, but is that true? There are so many other things in the pipeline which could be blocking or preventing the speed from happening, right? So one important thing is that very often GeoServer runs on port 8080, so we put some other kind of web server in front of it. And if we do that, can that web server support those many requests? That is one question which we had not even thought of when we made all these recommendations. Then we realized that we had to actually change the configuration of the Nginx web server which is in front of it to actually serve these many requests. Then another question comes, if forget the server and GeoServer, my application, my OpenLayers application is running in my browser, and my browser is hence making a lot of requests to the server for those styles. If you actually open developer tools and look at those styles you would requests, you would see that a lot of tiles go in pending. And why is that? Because if you're dealing with HTTP version 1.1, then at one time you can have only 6 or 18 or 14 kind of, depending on a browser, concurrent or parallel requests. But as you can see, I have so many layers and so many tiles. So what would happen is, even if I did everything else, my browser would still wait for those first 14 tiles to load and then request the next 14 tiles. So what's the solution? The solution is in HTTP version 2, which allows you to make unlimited number of parallel requests. So basically HTTP 2 allows you to have a sort of connected pipe as long as it is SSL between your client and server, and can request as many simultaneous requests as a client needs. So you need to enable that. If you enable that, your web server also should support it, and then OpenLayers should also support it, right? So you have to make certain parameter changes in the OpenLayer parameters to allow and use HTTP 2 requests by default, because the URL looks the same. So how would your OpenLayers app know that it needs to make requests by HTTP 2? So that is one parameter which you need to make in your OpenLayers configuration. And again, all of this is fine. How do you make these many requests in one go if you're testing with a tool like JMeter? So again, my client system cannot make that many requests even using Java and JMeter. So again, then we had to use JMeter distributed testing. After doing all of this, what are the results of the application? So again, the testing parameters which we said is, we have 600 users making WMS and WFS requests. We are using some WFS requests because the user wanted the geometry somewhere. Then we also were using cache tiles till zoom level 22. And then we were using dynamic tiles beyond that. That is, the tiles were not cached in advance. Only when the user made requests for them, that is when those tiles were created. This might seem a lot of work, but what did we finally get? Now this is the report from JMeter. So people may not understand what it means, but what you really need to look at is the number of the response time. And you would think that this response time is quite high, but this is because we were testing at the extreme end of 600 users, and the customer wanted responses within 3 seconds. These are all within 3 seconds with 600 users. Compare this to earlier when one user used to take 11 seconds, right? All of these numbers are actually, like, numbers don't lie. I can change some parameter, I can run the test again and see what number gets affected where. And that is when, with confidence, I can say that, okay, my app is now better or my app is worse, instead of going by gut feeling when I change these parameters. Just to understand what this means is, this is another graph from JMeter. What it tells you is that around 85% of all requests were within 400 milliseconds. Only beyond that, about 15% were between 500 and 2500 milliseconds, and only some 2% were beyond that, right? So this tells you that most of your users would have a good experience if you have a large number of users using your app at the same time, and only a few would get affected. This all is helpful because now we can say that the app is fast. The learnings that we had at the end of this project is that talk is very cheap. I can say my app is fast, my app is slow, but unless I have a JMeter graph and a JMeter test report which I can show that I made this change in the parameter and this is how my response time changed, it doesn't mean anything. Secondly, when we are talking about production usage, we need to do a load test. Very often, this is one step that we don't often do. In fact, many of you might have seen that there are some apps which don't work well because they went from a POC, proof of concept, to suddenly, okay, let's open it for everybody. And nobody did that load testing. Finally, when you're doing that load testing, you really need to think about what you're going to test. What are your scenarios? What are your type of users? How are they going to use your app? If you think about all of these things, then you will be able to set up the right kind of test scenario in JMeter. And finally, we can all think that we know the theory part very well. We can all make recommendations. But when it comes to actually implementing it, there are so many things which we would not have even thought of, which come back to us and tell us that, okay, you need to change this, you need to change it. It's the actual implementation of the recommendations took barely a day. But to do all of these other things and to get to the kind of results that we wanted, it took almost 3 months. So always be humble that there are many things which we don't know, and we will often face these new challenges which we hadn't even thought of. Thank you.
Thank you so much for the real life experiences, how you deal with the client and how do you solve the solution. Anyone has any questions for Devdatta?
I really face this situation when GeoServer is very slow. Now I understood actually what I need to do.
Right.
Thank you so much.
Yeah, and if you want, we can talk offline. There are many other things which I have completely forgotten about, which I have not covered. There are many small things which you can do to make things faster and better.
Thank you. Thank you.
Great. Anyone else?
Okay, thank you.
Thank you so much.